Hello everyone, welcome back to channel Geek Nepal. On the previous videos I did work on the data conversion, converting a number system from one system to another number system. That's what I did. Today I'll be working on the encode and decode instructions. Okay, alright, let's begin by adding a normally open contact and let's make it yum8125. Okay, and let's drag and drop this encode instruction already, and this is a source register. Let's say we have yum0. Okay, oh, not yum0. Okay, and d1 would be, let's say, d0. Okay, and this value, let's say we're gonna do 2. Okay, starting with 2 already. So I wanna add a couple more wrong here. Move, not move, I mean delete, select output, which would be, let's say, yum0. Okay, alrighty, and this one is I0. Okay, control C, control V. Let's make it I1. Okay, this one is 1. Okay, control V, I2. Okay, and yum2. Okay, let's simulate this program and see what does the encode do. Okay, initially when the yum0, these bits are not on, this value is 65535. Okay, what if the bit 0 is on? When the bit 0 is on, that d0 is 0. Okay, let's say when you have 1, it will be 0 again, because it will look for the least significant bit. Okay, that is on. If you have 3 bit on, it would be the same thing. What if 0, I0, yum0 is off? That would give us 1. Okay, and we are only using 2 bit, 1 bit, 2 bit. Okay, yum0 and yum1. Okay, so let's change this to 3 bit. Okay, so let's simulate it one more time here. So when the second bit is on, now we have 3 bits, yum0, yum1 and yum2. Okay, so the output would be 0, 1 and 2. Okay, when all the inputs are on, that would be 0. Okay, and when which one is the lowest bit? Okay, this one is the lowest bit, so it shows up here. When 0 is on, 0 is there. When 1 and 0 is off, and when yum2 is on, it will show 2. Okay, that's what it is all about, how many bits you wanna encode. Okay, alrighty, save this. Okay, open project 15A, where we will be doing decode. Okay, decoding of the program already here. Oh, that was 15A. Okay, let's do 15. Do you want to save the project? No. Already. And on this one, let's also add a normally open contact. Okay, let's say this one is I0. Okay, and we want to decode, right? Already. Data comparison, data conversion, boolean, binary, arithmetic, shift and rotate. Okay, we want to add a decode here. Okay, so let's say we have 1 here, and let's move that value to D0. What would be the decoded value? Okay, let's do a couple more of these here already. Decide this. Control C, Control V, Control V, Control V. Let's say this one is 2. You are sending that to 1. Okay, and let's say this one is 3. Sending that to data register 2. And when you have, let's say 10, send that to 4, 0, 4. Okay, so the output D1 in the destination register would be 2 to the power 1, which would be 2. Decode 2 would be 2 to the power 4, 2 to the power 3 would be 2 to the 4, 8, and 2 to the power 10 is 1024. Okay, which are the most common used numbers, right, in programming. So let's simulate the program. Initially this data register are 0 because the input is not on. When the input is on, so these 248 and 1024 are the decimal values. If you convert this to binary, you would get 000110. Okay, so these are the decoded value, 2 to the power 1 2, 2 to the power 2 to 4. Okay, so let me go over the help function here. What we are trying to achieve here is, let me explain with this example. When the input I0 is on the D20, like D20 has a value of 19. Okay, so what happens is, like it will be moved to 104 plus 19, 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 1 2 3 4. Okay, so that would be this bit here, which would be 127. Okay, so that would be 127. That's what we are trying to achieve here. Same thing here. If you are using the data register, you have 0 to 15 16 bit, 31 bits, and 32 33 34 35 36 37 38 39. Okay, so that's how you get 39. Okay, after the D10 you are moving that to D30, but D10 has a value of 39, so the total bit 39 would be here. Okay, so that's what is you are decoding. Now for the encoding here, if you look at here, you are looking for searching for the on bit here. Okay, that's what you are trying to achieve here, and you're looking for 64 bits starting at M4. M4 plus 64 would be M81 82 83 84, right, up to here. So you are looking 64 bits of memory register starting at M4 and moving that to D100. Okay, D100, and that would be, so the first search point would be 20. Okay, so since the internal relay M30 is the first point, okay, M30, okay, 20, this is the 30, M30 is the first search point. The offset from the first search point is 20, so offset would be 20. Okay, and 20 is stored to data register D100. Okay, that's how this encode and decode instruction works. Encode is mainly searching the input value, no matter how many there are, but it will basically, the priority would be the least significant bit. Okay, and decode would be basically you are trying to achieve exactly opposite of the encode, and basically you are like decoding the value based on the input given. Okay, alrighty, so that's all about encode and decode, and Thank you so much for having me. I will see you on the next.